So thanks everyone for taking time out of your Friday to come to this event. This is our next iteration of our SciComm seminar series. So I see a lot of familiar faces. So you know what we've been trying to do is just promote a lot of different angles of science communication and hopefully give especially our trainees some more exposure into the different ways that they can better their science communication. I'm really excited to introduce to you today's speaker. Dr. Maryam Zaringhalam graduated with her Ph.D. in molecular biology from Rockefeller University in 2017. So she's very familiar with how programs like ours work. After graduation, she completed the AAAS Science and Technology Policy Fellowship within the National Library of Medicine. She now continues to work in that office as the Data Science and Open Science Officer within the National Library of Medicine's Office of Strategic Initiatives. She also is a senior producer for the science-inspired storytelling series, The Story Collider. And in this role, Dr. Zaringhalam works to enhance capacity in both the biomedical research community for data science and open science, as well as promote diversity, equity, and inclusion among the research workforce. So I won't share too much of her journey because I know she's going to talk about it as well. With that, I'll transfer it over to Maryam.
Right. Thank you so much for that introduction and for having me this afternoon. Or I guess it's still the morning for you all. And just a quick disclaimer, I'm sorry that I'm joining from my backyard. I tested positive for SARS-CoV-2 on Monday. I'm doing fine, but I am isolating away from my partner. So it was either a mask on indoors or a bit of background noise, but hopefully it's the soothing sound of the outdoors. So I am going to switch to sharing my screen. Oh, actually, let me first go into presentation mode. There we go. And if you can let me know whether you see my slides and not my presenter notes, that would be much appreciated.
Looks good.
Great. All right. So I'm really excited to be with you all this morning or afternoon in DC and just share some of my thoughts on science communication and policy from my perspective as someone who sort of straddles both of those spaces and has kind of tried to find to bridge them in a way that is hopefully meaningful for the things that I care about most. And I want to focus specifically on storytelling as a way to kind of open up the scientific enterprise, since I see it as a really powerful tool for lowering barriers to entry into conversations around science. And in doing so, to help promote greater confidence in the process and products of research and to advocate for policy and create and work with policymakers to solve some of our most pressing challenges ahead. But before I got started, I first wanted to tell you a bit about how I got started in doing this kind of work, especially since I am still relatively early in my career. And I also want to note that the perspectives that I will share throughout this talk are my own and not those of my employer. So when I started grad school, I very much thought that I was going to be an academic. I had this idea that by the time I was 30, I would be, on the tenure track, raring to go. But very quickly, I realized that academia was just not the right fit for me. I felt more like I was, a generalist rather than a specialist. And so becoming really hyper specialized kind of felt claustrophobic for me. And so I got really interested in science communication, around the same time that I'm realizing academia might not be for me, which was in my first year of grad school. I also started getting really interested in science communication. And I started a blog in my first year called Art Lab, which I don't think exists anymore if you type it into a Google search. But it was a blog really for myself, my friends, my family, that was exploring the creativity and curiosity required to really be a scientist. And that sense of curiosity fueled me personally in in my sort of graduate career to take on a high risk, high reward thesis project when I was doing my rotations in my first year. And around my third year, I started getting really promising results. My goal was to sort of develop this high throughput technique that would detect this very slight modification of an RNA base using a combination of high throughput sequencing and computational approaches. And so, I'm getting these really promising results and, feeling pretty good about myself. Even though I didn't want to be an academic, I still wanted to be a successful graduate student, whatever that means. But that kind of boost to my ego quickly went bust when around that same time as I was getting interesting, promising preliminary results, 4 papers came out at exactly that same time. Oops, I didn't mean to have it so dramatic, but it did feel very dramatic. These 4 papers were all laying out the exact method, that exact computational approach that I was working on. And, it wasn't a case of any kind of scientific espionage or anything like that, but really, I think the result of a lack of communication from across these different research groups that were operating in silos. And that stems, I think, from greater incentives around competition in biomedical research, I think in probably all lanes of research, rather than cooperation, rather than collaboration. And so around this time, I was sort of in crisis because I needed to finish my graduate project, but I had no project anymore. And so, what was I going to do? And around that same time, I wound up learning about the open science movement, which I'll talk more about shortly, and challenges around reproducibility of research results. And I decided to do a sort of meta-analysis of these papers to see how well they agreed with one another. And through that meta-analysis, engaging in this kind of work, getting into, data sets that were being shared, getting into, analytical tools that were developed for these approaches and trying to download them myself or reverse engineer them myself. I started to get, really curious about ways that we can sort of incentivize greater collaboration and thus greater scientific rigor from a sort of science policy perspective. And so I got really interested in, what might a career in science policy look like? What might it look like to step out of academia and try to make policies and programs that make the research enterprise operate in a way that's better? And so I started using my communication skills to start to explore what careers in policy might look like, because there wasn't, a ton of education at Rockefeller about science policy as an option. And I kind of had a vague sense that it existed because we had this great science diplomacy course that was offered for no credit. But I decided to do some exploring of my own with 2 of my graduate school colleagues. And with absolutely no podcasting or audio mixing experience, we decided to start a podcast exploring the intersection of science policy and advocacy that we called Science Soapbox. Using kind of this platform of a podcast to incentivize people who might not have ever thought of talking to 3 graduate students to come and talk with us. Because, an amazing secret is that if you say you have a podcast, all kinds of people will agree to talk to you and share their stories and their career paths with you. And what's really brilliant about podcasts is that you can share, we then had this opportunity to share these stories and experiences with our peers who were also looking for what other kinds of careers might be out there. And so we got to talk to people like Kei Koizumi, who is now the chief of staff for the White House Office of Science and Technology Policy, who gave us the sort of ins and outs of what federal budgets mean for research and development. We got to talk to Brian Nosek, who is the founder of the Center for Open Science and has been leading several projects into the reproducibility of research experiments. It's actually his work that got me sort of on the open science train. And we also talked to Francis Cologne, who was at the time the deputy science advisor to the Secretary of State, who was then John Kerry, about how she transitioned from studying neuroscience to doing amazing things like working to restore diplomatic relations with Cuba through science as a bridge. And a common thread throughout these interviews was that many of them had done the AAAS Science and Technology Policy Fellowship or had worked with people who had done this fellowship as a launch pad for a career in science policy. And for those of you who aren't familiar with the fellowship, it places scientists in either the executive branch or the legislative branch to work for 1 to 2 years, bringing their scientific expertise into government in a variety of different ways. And I wound up getting this fellowship and was placed at the National Library of Medicine, or NLM, as you might hear me refer to it, within the National Institutes of Health. And there I stayed after my fellowship ended as the data science and open science officer. And for those of you, just as a sort of, because data science and open science can be kind of jargony words, what I mean by data science is a scientific and methodological approach to understanding data. And open science is then a way of doing science, a paradigm in which the products and processes of research are made broadly available and usable. And my institute sees this really deep connection between data science and open science, because practicing science in open ways gives us more data on which to operate and drive data science forward. And as a national library, the NLM being the world's largest biomedical library, these two areas are really embedded into our mission. When I came to NLM, I had this kind of stereotyped idea of what a library is, what a library does, as sort of being this analog environment with stacks of books or journals. But really the role of a library is to connect people. In our case, you know, they might be biomedical researchers or clinicians or policymakers or members of non-technical audiences with the information that they need the most when they need it the most, all with the goal of advancing, in our case, biomedical research, clinical care, and ultimately human health. So a lot of the work that, so I do a lot of work these days, thinking about how we can train an existing and future generation of biomedical researchers who are equipped to make sense of big data to advance biomedical research, while also taking into consideration, you know, things like important things like ethics, concerns around privacy and security, as well as Indigenous sovereignty and the rights that come with that. And I also work on policies around how we can incentivize researchers to harness the power of data using more open knowledge production and sharing paradigms. And ultimately, you know, the ultimate goal to open science for me is to make research more cooperative and collaborative so that the products and processes of discovery can extend as far as possible. And so when we think about this as the goal of open science fundamentally becomes about communication with various stakeholders in research. And this is especially important when I think about, you know, data science, because it is so incredibly interdisciplinary. It's very fast moving space. It involves collaborations between people with deep subject matter knowledge, people with deep computer science knowledge, people with a deep understanding of statistics and mathematics, and also with people who have the expertise that is born of lived experiences, whether they are patient advocates, community leaders, and so on. And so there are a lot of people that we have to think about communicating with in order to make open science really succeed in this vision. But often, in conversations that I've seen, it's often thought open science is sort of thought of as researcher to researcher communication, maybe researcher with health professionals, with educators, with librarians, and very often non-technical audiences who aren't steeped necessarily in the deep weeds, the deep jargon of science, remain left out of the equation, much to the detriment, I think, of open science. Because for science to be, again, as collaborative and cooperative as possible, we need to be engaging as many people as possible to hear their input, their concerns, their ideas, and really crucially to build and earn their trust, their confidence in the research community. And this is especially important when considering emerging technologies like those that come from data science. And so, that trust building, I think, is especially important when we consider statistics like these that come from, I guess, now a kind of outdated Pew Research poll that found that 58% of Americans feel that computer programs will always reflect human bias. And I think that often within science, within the research community, it's really easy to dismiss this lack of trust as like, oh, people don't know enough. But once they get the technology, once we explain all of the facts to them, once we show them all of our greatest graphs, they'll love it. They'll come on board. They'll be really excited and eager to adopt these technologies, to use, algorithms more in their everyday lives. But buying into that kind of thinking, that people just don't know enough, and once we educate them, they'll be on board, really does the scientific community a huge disservice. It's really critical to remember that the history of science, and particularly biomedical research, is riddled with examples of human abuses done in the name of, advancing science. And when we consider that general social trust is negatively correlated with perceived risks from hazards, this mistrust is very earned. Our history is riddled with unethical testing, with withholding treatments. The field of gynecology was born of experiments done on enslaved women and children. And there are entire communities who have been neglected by the research community. So again, this skepticism, this mistrust really does come from an evidence base, even if we don't like to see it, and even if it's really uncomfortable with us to grapple with as a community. And these harms persist today when we think about, data science applications towards, human health, towards biomedical research. There are countless examples of, for example, bias being baked into facial recognition algorithms. So Joy Buolamwini at MIT found that 3 of the latest gender recognition AIs could only correctly identify white men with accuracy. For dark-skinned women, that accuracy dropped to just 35%. And we can also consider studies like one that was published in Science in 2019, where researchers found that an algorithm that was used on more than 200 million people in US hospitals every year to predict which patients would need extra medical care, that algorithm favored white patients over Black ones, reflecting systemic inequities that have caused healthcare disparities. And so, even though I work in data science, and even though I'm really excited about emerging technologies in my professional life, I am really wary of them in my personal life, particularly as a woman and as a person of color. And so when I communicate with folks who are skeptical, I try to keep my own skepticisms that stem from my lived experiences and my own concerns in mind. rather than approaching communication as this sort of one-way stream of me having all of the answers, of having all of the information, trying to convince people to come and see things my way. To meet people where they are, to hear their input and use that input, use that expertise to make the science better as sort of a two-way bridge. And so to do this has required my rejection of what's known as the deficit model of science communication, which some of you may be familiar with. And it's this model that's really often prized and held up in academia, that if you just present the facts, present the data points, present your conclusions, again, they'll get it, right? But within the social sciences and the field of the science of science communication, we've known that this form of communication is deeply ineffective when communicating with people outside of our small, tiny communities that are already bought in, our small little kind of academic bubbles. And so an alternative to this model that I'd like to discuss more with you all is the participation model of public engagement, which simply rests on meeting people where they are, having conversations with them as peers, as equals, recognize that they have certain expertise, viewpoints, and ideas that are extremely valuable for you as you continue your work. Whether you end up, in an academic setting or you end up in the policy space or somewhere else. And so what I'd like to explore more with you all as I move through this talk is how shifting to this participation model can help us think through two questions, which are really front of mind for me in my work, thinking about program and policy development in this space. And the first is, how do we communicate with non-technical audiences about emerging technologies? And the second, and this is very, intimately related, is how do we have conversations that make those technologies better, that factor in the expertise and experiences of those we're communicating with, to really ensure that we're making, doing the best, most robust, most rigorous science possible. And I find that looking again at the social science underlying the science of science communication is a really good place to start when thinking about how to answer these questions. And Dan Kahan, who studies the science of science communication, particularly to audiences who are skeptical, notes that people acquire their scientific knowledge by consulting others who share their values and whom they therefore trust and understand. And so researchers have looked into how to better characterize what hallmarks effective experts have that make them both trustworthy and understandable to their audiences. And so I'd like to sort of go over the work of two psychologists, Susan Fiske at Princeton and Sidney Dupree at Yale, who study perception and stereotype formation. And they found that in order for an expert to be effective, they need to have two qualities. The first is competence. So does my audience perceive me to be knowledgeable, perceive me to be capable, perceive me to have mastery over the science or the information that I'm communicating to them? And the second is warmth. Does my audience perceive that I have their best interests at heart, that I am leading with my humanity, that I share maybe their values or can understand their values? And so they asked participants in a study to rank different professions based on their warmth and competence. And they gauged their reactions to these different professions to see, how did these audiences feel about people who just say, hi, my name is Maryam and I'm a scientist. And this is a very, very simplistic schematic outlining, sort of summarizing what they found. And on the x-axis, we have warmth, and on the y-axis, we have competence. And people within professions who were perceived to be very competent and very warm were viewed with admiration. Those who were viewed to be warm but not terribly competent were viewed with pity. Those who were perceived to be not terribly warm and not terribly competent were viewed with disgust. And those who were viewed as being not very warm and highly competent were viewed with envy. And scientists and engineers fall into this camp. Now, me, when I first read this as sort of an awkward nerd, growing up, feeling like an outsider, I was like, hey, this is pretty cool. People might envy me. People might be jealous of me. That sounds fine. But they took this experiment a step further, and they wound up hooking up participants to their faces to different, sensors, and they read out different scenarios of people in these professions. And they found that, if you say there's a scientist on a street corner trying to hail a taxi cab, it's raining, and a car just drives and splashes a bunch of muddy water up on them. They found that they could detect sort of an upturn of their lips into a smile. So it was sort of experimentally verified Schadenfreude, I guess. And this enviable quadrant isn't really, the kind of place that we want to be. So how do we land ourselves up into that more warm, more competent quadrant to be viewed with feelings of admiration? And so here, I'd like to introduce storytelling. Finally, I've gotten to storytelling as this super effective way to kind of get us into that admiration zone, to be more warm, to be more relatable, to hint at our values, our motivations, and our concerns with our audience, all while also being understandable, while being perceived as being competent, of having really knowing our stuff when it comes to the science. So how can we use storytelling as sort of an entry point into that competence? And so I come at this from the perspective of a producer for an organization called the Story Collider, which for those of you who might not be familiar, we bring true personal stories about science to live audiences around the world, and also through a podcast that comes out every week with 2 stories recorded from our in-person and virtual, now in pandemic times, stages. And so the general idea here is that, science is all around us. It belongs to every one of us. And so all of us have some story to share, whether we are practicing scientists or we haven't taken a science class since grade school. And I know that stories can be a kind of like jargon term on their own. What does that mean? Is it a fairy tale? Is it a journalistic story? And so for us at Story Collider, we define stories very simply as being true and personal to the teller. And it's having a beginning, a middle, and an end. And really crucially, in the middle, something changes. Now, what that changes can vary, but it's fundamentally bound up in a moment of insight or clarity or discovery. And that includes discovering that we didn't have all of the answers all along. And so when we think about applying storytelling to, our scientists, you all are the main characters. Discovery is the central plot line. And science is then the evolution of how we understand the world around us, how our understanding of that world changes. And so stories are an excellent formula for delivering science content, guiding our audiences through the process of discovery and what it means to us personally, and hopefully what it can mean for them. And opening up that kind of dialogue from a point of relationship building. And when you think about it, we use stories all of the time to make sense of the world around us. We use them to get to know each other, to get to know potential collaborators or friends. We use them to get to know, to make sense of who make crucial decisions about our everyday lives. And so stories are ingrained in us. We're hardwired to take them in a way that we're not hardwired to absorb cold, hard facts delivered in a vacuum. And because really stories provide the context in which discovery happens, and they give us characters that we can relate to, that we can bond with, which is why they're really effective information delivery vehicles. And so when we work with scientists at the Story Collider, and really anybody, on how to tell their stories. We're careful to tell them to bring their experiences, their fears, their honesty, their sense of humor, their sense of indignation, their motivations, the stakes of their story, why it matters to them, to speak their truth, to talk from a place of, sharing their values, their unique voice, and their vulnerability. In other words, we tell them to bring their whole selves into the work that they do. And bringing your whole self and creating space to bring to allow scientists and allow anybody to bring their whole selves while telling a story of science is really crucial for challenging stereotypes of who does science, who has access to science, who does science belong to. And in challenging those stereotypes, we offer entry points into conversations around science. Again, leading with our humanity, leading with our unique perspectives and values. Now, I understand that all of this is kind of theoretical, so I want to show you a few examples that I've brought on how you can use stories to establish open lines of communication. And here I've selected a few examples that are specific to health and biomedicine. So we can use stories to kind of explain our science or provide an entry point to why we care about the science that we do, why it matters to us through our own personal experiences. And so this is a story from a neuroscientist, Dr. Bianca Jones-Marlin, that she told in 2018. And so this is the start of her story.
I have a Ph.D. in attraction. I should clarify. More specifically, my doctoral studies looked at the molecule that regulates the laws of attraction, a molecule called oxytocin. You may have heard about it. It's like the love drug. Nonetheless, it's released from our bodies during certain things that foster communication and foster connections, like holding hands, eye contact, all the way to uterine contractions and breastfeeding. And so it helps to foster these relationships. And what my doctoral studies looked at was how oxytocin changes a very particular type of attraction, the attraction of a mother to her child.
And so from here, she goes into the story of her own, becoming a mother for the first time. And can refer back to the science and kind of ground the science in her own experiences. We can also use our stories to show our relationships to the communities that we work in and serve. Because scientists, I have been workshopping for some time, how do I get away from saying, communicating with the general public when scientists are members of the general public. And so, we don't live up in ivory towers. We have real personal experiences that provide the stakes, that can provide stakes in the work that we do. And I think this is especially true in biomedical research and in human health. So here's a story from Dr. Kenneth Haller, who is a pediatrician in St. Louis. And he tells a story about his first encounter with a young patient with a mysterious illness, which he would later learn was one of the early patients in the HIV/AIDS epidemic. And so here's his story.
I didn't know then that this 27-year-old guy I would never meet would be one of the first gay men diagnosed with something that would briefly be called GRID, for gay-related immune deficiency, and later would become known to the world as acquired immune deficiency syndrome, or AIDS, and that a virus that would be dubbed human immunodeficiency virus had already spread to many of my friends, and that many of them would die in the coming years. I didn't know then that this day would mark the split between before and after in my life, and that I would be one of the survivors to tell the story of my people in the time of plague.
And so scientists can use our stories to share why we're invested in the work that we do, and to use that investment as a doorway to then talk about, go deeper into the science. Once we've established that, we do often have very real, very personal stakes in the kind of work that we do. And we can also use stories to instill hope and galvanize action while still addressing where science falls short. So I have a clip from Dr. Tracy Dixon Salazar, who is a neuroscientist and a rare disease advocate, but she wasn't always that. And she tells her story about her daughter's epilepsy, which doctors couldn't find a cure for. And she tells us about how she is inspired to take matters into her own hand because she just can't find the answers that she's seeking. And in the middle of the clip, I'll note here that you'll hear a little clap sound, and that jumps us from the start of her story, where she decides that she'll start taking science classes, to the end of her story, where she has become a neuroscientist and has found a promising treatment for her daughter's epilepsy. I know that I gave away spoilers, but I promise you that she tells this much better than I can.
I just want to know what causes epilepsy. I don't understand this. I need to go to college and take some English classes. It turns out that my English is fine and that scientific papers are not in English. And medicine is yet a third language. And so I enrolled in some scientific classes and I fell in love with the subject. And if you think about it, you really shouldn't have to get a Ph.D. to figure out what's wrong with your kid and to do the research yourself to find the medicine behind the science and then convince the physicians to try that. But a mom's got to do what a mom's got to do till science and medicine catch up, and we'll just keep doing it.
And so she is able to use her story as a way to advocate for the need to do rare disease research. That not everybody should have to spend years and years and years becoming a scientist to find a treatment for their child or their loved one. And so, really what I hope you've gotten from this very small sampling of some of our stories is that stories are this really powerful way to allow our audiences to see themselves reflected in the science that we're trying to convey. And stories allow us as listeners to empathize with the characters in the story, to see their struggles, their passions, their interests, their motivations as our own. And seeing ourselves reflected in that work is really the first step to feeling like we belong in science, that we belong in a conversation around science, regardless of what credentials we may have. And this is especially an essential step in opening up science to those who may not have felt like science was open for them. This could be, whether we're talking about policymakers or people or other communities that we're trying to advocate to. And so there's been some really interesting work done around, what happens when we start to shift stereotypes of scientists in instilling a sense of belonging and in increasing access, to science and to discussions around science. And so this is a study that was done by educators in part at a community college in California. And what they did was they assigned a series of homework assignments that required community college students who didn't identify as, science people, they weren't science majors, to read or listen to personal histories of scientists from a wide range of backgrounds in their introductory biology courses. And these are requirements in order to graduate. And so this included stories from Story Collider, as well as TED Talks, BBC radio interviews, and so on. And so when the classes began, they asked the students to, say what they thought about scientists. And they said, scientists are people that do experiments. They're especially intelligent. They're people like Albert Einstein who search for truths. And at the end of the course, they asked the students again what they thought. And they answered that scientists are all types of people. There are people who do experiments, they're cheerleaders, there are people like Rosalind Franklin who discover things and are passionate and dedicated. And those altered stereotypes mattered. First, for a number of reasons. First, it happened that students that had less stereotypical views of science, of scientists, actually performed better in the class, whether or not, they are like, yeah, I'm going to be a scientist now. And it also altered ideas about what science fundamentally is. And so this is a quote from Gina, who is a Black and Native American student who took this course. And she's talking about a scientist that they read about or listened to, Dr. Day. And she says, as a strong Black woman representing women and people of color in a white male-driven field, Dr. Day defies what I believed about people who do science. I wonder if the questions of science require diversity, collaboration, and personal passions in order to be answered. And this is incredible that such a small intervention, that just sharing, personal human stories about the people driving the work, changed these students' ideas of, again, what science is and who gets to do science. And so stories are this really beautiful and powerful way of helping us build bridges between experts in fields like ourselves and the audiences that we seek to communicate with. And excuse me, to help them feel like they have, that they can have a say in the science that we are driving forward. And, one-way conversations, this deficit model approach is just, again, not going to get us there. And so that brings me to that second question that I ponder about often is, how do we have conversations to make those technologies, those emerging technologies, better? Once we've opened up, how can we open up bridges to conversations in a way that invite our audiences to share with us ways that we can drive the science forward together? And I think to answer this, first, I had to come to terms with the fact that there's no, one size fits all approach. There's no one elevator pitch that is going to invite people into a conversation where we can begin to collaborate and work together. Because it ignores, if you try to come up with a one size fits all approach, it really ignores that there's just, a diversity of views and perspectives. So, for example, this is a survey that was done by the Center for the Governance of AI that surveyed over 2,000 Americans to get their thoughts on AI and AI governance. And they asked these respondents, how much do you support the development of AI? And it really depended. You got, a different breakdown of answers depending on age, sex, and I don't like how they, asked in this sort of binary construction of anyway, or in this binary construction of race, but you get different answers there based on income and, educational specialties. So you get a diversity of responses and views based on, different characteristics, and these intersect in different ways. And so, this is really just to say that when if I'm going into a discussion around AI, my approach to that discussion is going to vary very, very quite significantly, depending on who I am talking to. That framing is really going to be critical because it sets the tone for future engagements that you may be having with your audiences, future conversations that you're going to have. And you may also have to undo some framing set up by others before you. And again, so there really is no one size fits all approach for creating entry points into conversations around a given topic in science or a given technology. Because even within a single, very specific niche area of science, there are going to be a range of applications, of downstream consequences, of opportunities, concerns, fears, points of excitement. And these are all going to serve as a different frame that you can then use to walk down a discussion with an audience. And so it's really critical to listen to your audience, to hear what they're saying, to give your audience opportunities to ask questions and to respond accordingly. And of course, if you don't have a response handy, create opportunities for following up and discussing further. And while I don't, recommend coming in with a set elevator pitch or spiel, I do recommend preparing nevertheless, thinking about what stories can I tell, what experiences can I draw on, whether they're my own or my collaborators or people that I work with. And so first consider, who is your audience? Who is it that you're entering into a conversation with? What is it that you're trying to communicate to them? What is it that you want them to walk away from the conversation knowing, or what is a question that you have for them that you want their input on? Why does it matter to them? And this is really crucial because people are way more likely, this is, I think, a basic rule of human nature. People are way more likely to listen to you when they understand, what's in it for them. And then taking all of that into account, how will you draw those connections with your audience? What are the stories about yourself and your work that you can tell of past collaborations, of lessons you've learned that may create entry points into a conversation with them? And then finally, and really critically, consider, are you the right messenger for this topic? Not just in terms of expertise in your specific field, but also in terms of lived experiences, of a common vocabulary, of common values that you can use again as entry points. What's really wonderful about, having a community is that you're all in a position to, point to other people who may be, the better messenger for a given topic, or invite other people into a particular engagement or conversation. Because who we put forward as the storytellers of our science can really go a long way to making people feel, more likely to engage, more comfortable engaging in conversations. So that you can ultimately, get their input, have more rich and robust discussions about how to together move a technology or a field of science forward. And so, with that, that sense of belonging, that sense of opening up entry points into discussions around science is really key to opening science and ultimately making for a better science. No matter if you wind up in policy or in academia or in advocacy, no matter where you are, having these kinds of conversations ultimately makes science better. And so with that, I thank you for your attention, and I'm happy to answer any questions that you may all have. And I'll stop sharing my screen.
Thank you so much. That was a fantastic talk. It was really great to hear all of your experiences. I'll start out by actually asking a question that we had in the Q&A, and it looks like we have somebody else that'll ask the question after that. So the first question is, given, kind of especially current economic times, are there efforts to better compensate AAAS fellows, especially for many of us trainees considering careers in industry that may be a little more lucrative? How do you kind of balance pursuing these passions with sort of these opportunities to kind of make more money?
Yeah, that's a great question. So the AAAS science, the fellows are compensated according to what's called the general schedule for federal employees. So I believe that you come in as a GS-12 on a 1 to 15 scale. So the answer is you have to change the pay grade for the entire federal general, what federal employees get, because it is tied to that, and it's tied to certain restrictions about, I think, who about what qualifications you have to have. That said, if you come in having a certain number of years of experience, you might get compensated more. I came in at general schedule 12, step 1, and for those of you who might not be, I think now it's in the $80,000 range. When I started, I think it was $79,000. The really nice thing about federal government is there's a lot of pay transparency. So I'm happy to talk about pay, but unfortunately, it's kind of in the hands of what feds make. And yeah.
Yeah, that makes a lot of sense. We have a comment in the chat. If you could post your contact info again, just so that people can follow up with you.
And then my story collider, depending on what you want to talk about.
Awesome. There's any other questions coming in. We have another question from Lucas. And it's a wonderful presentation. I appreciated your framing of science communication as a tool to be developed rather than some sort of art. But he wants to know, how do you approach demonstrating the importance of these tools to scientists? And I think it's a great question for you to answer.
Yeah, that is a great question. So I think, it depends on what the scientist that I'm talking to is most interested in. So I think right now, there are a number of people in the biomedical research space that have seen misinformation and disinformation and how that has impacted our response to the COVID-19 pandemic. If I'm communicating to a scientist who is very concerned about misinformation and disinformation, then how I would convince them is saying, when we exclude ourselves from the conversation, that creates more opportunities for that to crop up unchecked. If I'm talking to somebody who may not be interested in that, but is it really interested in, for example, writing better scientific publications, there is some evidence. It's not, I went in, downloaded their data, crunched some numbers. It's not as compelling as, in the interest of full disclosure, as they make it out to be. But there is some evidence that, writing more clearly, I think that we can all appreciate that writing more clearly makes people, actually want to read your paper. So that they're not stopping every, 1 to 2 sentences to look something up or read it 5,000 times and then finally give up. I think sometimes there's, when I was in at a conference and there was this PI next to me falling asleep that I respected a lot. And when he woke up, I was just like, gosh, I didn't know that fancy academics fall asleep during talks too. And he's like, I have no idea what they were talking about. So, you can also talk to people about, more effective communication skills can also help you find collaborators, also can contribute to, more citations, might translate to better chances of research funding, although I can't guarantee anything in any of these spaces. But, there is also merit to speaking more plainly and in a compelling way to advance our own careers.
Thank you. We have a sort of a follow-up question to that. So how do you conceptualize applying these approaches to science communication in building power within and through the scientific community? So what do you see as the role of the scientific community in fighting for justice and equity, especially with regards to the dangers of social genetics, things like the anti-trans bills that have been recently passed, et cetera?
Yeah, that is a great and complicated question. I think that, and I could probably talk about it for hours. And so if you wanted to, you could get in touch with me and I'd be happy to talk about it more. I can also go past the hour if people would like, but I want to be respectful of people's time. I think that there is a strange, there is that a pseudoscientific of all of these really awful manifestos and bills and things that try to sort of distort or contort or reshape science to serve whatever end they are trying to serve. And so I think that, being an effective communicator can really help walk people through why certain things are nonsense, why they are not rooted or grounded in science. What are the kinds of logical tricks that people are trying to employ in order to, convince people of having ideas that run counter to human rights and justice. And so having, effective communication skills can really help effectively debunk these bad theories, I don't even want to call them theories, they're just nonsense. And so, you can do that in a number of ways. I've seen people do it really effectively on social media or through blog posts or just in conversations with family members who may not be on the same page as you, although conversations with family are often, I think, way more difficult to have than trying to convince a stranger of anything. And so I don't quite know if I answered your question, but I think, in order to effectively combat these ideas, we have to also be able to walk people through our work, to show our work and show why theirs is bad.
Yeah, thank you. And I know we're just about at 12, so if people have to leave, totally understand. We do have one last question that's in the Q&A, and I think might be a good one to end on, especially for the trainees in the audience. So how can someone prepare for a career in policy or be competitive for something like the AAAS fellowship, especially coming from a small research institution and short of starting a podcast?
Yeah, that's a great question. So, and I'd be happy to talk. This is something that I offer to everybody who is interested. Email me and I'd be happy to talk about, putting together a competitive application and sort of like, what are the things that you should be looking at on the application website to prepare one. But I would say in terms of skills to build, communication with anybody is really, really helpful. If you do outreach activities, if you teach or TA, if you have a blog, if you, volunteer, if you have ever done a Hill Day, it doesn't have to be a podcast. It doesn't have to be anything super formal. But really, one of the things that they're looking for in the fellowship is that you are a strong communicator. Participating in this kind of series is also a really great thing to highlight, because ultimately, policy is all about communicating, distilling complex information into actionable, digestible sort of bites. And so if you can show you can do that, that's really helpful. The other thing that they're really looking for is that you actually have an interest in science policy. So there are a lot of people who will just apply to the fellowship because they don't want to do academia. They haven't ever really thought about policy. And so they just, go ahead and give it a go. Ways that you can demonstrate that you really care about policy. Again, if you volunteer in certain groups, if there's like a community or journal club that you can start up at Scripps, that can be really helpful. There's also communities like the National Science Policy Network that you can join to demonstrate your interest and get involved. Other kinds of advocacy groups that might be around in your area. So just really, I think that like demonstrating that you have a real vested interest in science policy. You don't ever have to I didn't really know what science policy was. That's the point of the fellowship, to figure it out. But what they're really looking for is a demonstrated interest in policy and the ability to communicate well.
Great, thank you so much. And I think with that, we'll let everyone go. We don't want to keep you too long past the hour. So thank you all so much for attending. This webinar has been recorded and will be available on our YouTube channel at some point in the near future. So keep an eye out for that. And thank you so much, Maryam, for your talk and for all the information you've shared with us. This is really informative and really interesting. So with that, I hope everyone has a really great weekend. Thank you.
Thanks so much.